Hello viewers, you're welcome to another episode of our JAMB preparation. Today we are going to be taking some questions you cannot escape in JAMB Chemistry. You know, there are some topics that they repeat questions from often and often. It's like a constant question. So I've made some research and I'm going to be bringing to you such questions. So I'll give you the question and I'll tell you how to go about the answer. I'll tell you how to go about the solution. So without wasting much time, let's dive in. But before we do that, if you are new to this channel, my name is Excellence Simplified, and on this channel I bring to you questions and tips on how to go about your academics and succeed. So stay with me. If you've not subscribed to this channel, please click on the subscribe button and like this video, share to others, and let's dive into it. All right, so the first question here, we don't know why do I some give question on that. They'll pause. All right, so let's look at this question. Question 1. The general formula of haloalkanes, where X represents the halide, is dash. And options were given. Anytime you see a question like this, the first thing to do is to smile because it's a bonus question. You cannot fail any question like this. You cannot. All right, now if you want to solve this, if you want to get the answer, one thing you need to note is carbon is tetravalent, meaning carbon must have 4 bonds. So even if you don't know organic chemistry, you can get this one right because carbon must have 4 bonds. So knowing that, you know that carbon will have 1, 2, 3, 4 bonds around it. Now, the general formula for haloalkanes, halo here represents the halogens as chlorine, fluorine, and the rest. But here in the equation, they said X should represent the halide. Now, an alkane has saturated bonds, meaning you have something like this. If you have something like this, see, like this carbon here, you have 4 bonds around it. If hydrogen is saturating everything here, if you check now, carbon is having 4 bonds, right? So this will be CH. How many H here? 4. This is an alkane. Another thing is, another one, what if it's 2 carbon? If it is 2 carbon, we can have something like this, 1, 2. Then we ensure that hydrogen fill up the whole place. So 1, 2, 3. If you check this one now, I have 4 bonds, 1, 2, 3, 4. Now we give this one 4 bonds too. Please take note, carbon should not have more than 4 bonds. If it should not also have less than 4 bonds. If you check this one have 4 bonds, 1, 2, 3, 4. If you check this one have 1, 2, 3, 4 also. Now, if we want to attach halide, whether chlorine, fluorine, all you need to do, we cannot attach chlorine here or any of the halide here, X. Because if we attach it here, carbon will be having more than 4 bonds. So if I want to attach halide, what I'll do is to remove 1 hydrogen. Then I'll put my halide. Good. Now, if you check the general formula of alkane, the general formula of alkane is simply CN. Remember, H was here before. This alkane. CN H. Now, if you look at this, okay, let's start with this one. How many carbon do we have here? 2, right? So let me say C2 H. How many H? 1, 2, 3, 4, 5, 6. We have 6 of it, right? Meaning you can say Cn H2n plus 2. Because now our n, in this case, now our n is 2. So 2n, 2 times 2 will be what? 4. 4 plus 2 will give us 6, right? So this is the general formula of alkane. If you want me to test again, let me test with this one. CH4. Let's test with that one. This will be Cn. Our n here is what? 1, Nabi. So here we'll be having H2n. 2 times n, our n is 1. 2 times 1 is what? 2. Then plus 2. So that will give us 4. So you see we have the same formula. So this is the general formula of alkanes. But now if I remove 1 hydrogen because I want to put halide X. I've removed 1 hydrogen, right? So what will be happening is, since I've removed 1 hydrogen, here will no longer be H2n. Because I've removed 1 hydrogen, so it will be H2n plus what? 1, then X. Please let me pause. All right, so basically this is the general formula of the haloalkanes. So back to the question now. The question says the general formula of haloalkanes where X represents the halide is what? Is it this one? No, no, no. Where do you see the answer? Here, right? D. CnH2n plus 1 X. If it is only alkane, it would have been CnH2n plus 2. But since we are adding halide, we remove one hydrogen. That is why we have D as our answer. So this is the answer to this question. All right, my fans, let's look at question 2. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. This phenomenon is referred to as dash. Now, we don't do guesswork here. Don't guess. Let me explain all the terms here, then you tell me the answer. Now, efflorescence. If you have something if you have a substance that is hydrated, that is water is with it, and you expose it to the atmosphere, and that water that is in that substance is lost to the atmosphere, that is called what? Efflorescence. So if I have something, a substance, water is in it, then as I have that substance and water is in it, and I expose it to the atmosphere, the water now evaporate, the water now leaves the substance. What you now have, that process is called what? Efflorescence. And any substance that can do that is called an efflorescent substance. Do we get that? Efflow, give out, water is going out. Now, deliquescence, on the other hand, is any substance that, this is a substance, when you expose it to the atmosphere, it will absorb water. Take for example your salt. If you expose it to the atmosphere, you agree with me that your table salt will absorb water, right? Absorb moisture and form solution. So deliquescent substance is any substance that absorb moisture from the air and dissolve in that moisture. That is, a form solution with it. Hygroscopy and deliquescence are very similar, so take note now. Hygroscopy, they also absorb moisture from the atmosphere, but they don't form solution with it. They don't dissolve in the moisture. Take note to deliquescence, they absorb moisture and they dissolve in it. That is, they form solution. Hygroscopy, they still absorb moisture, but they don't dissolve in it. That meaning that the moisture will be, or the water will be one place, the substance will still be one place. They don't dissolve in it. Like concentrated sulfuric acid does this. So that's the difference between deliquescence and hygroscopy. Then hydrolysis. Lysis means breakdown. So hydrolysis, you are using water to break bond. So back to the question. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become anhydrous. This phenomenon is referred to as what? Efflorescence. Remember, it's efflorescence that is giving out water to the atmosphere. Deliquescence is absorbing water and forming solution. Hygroscopy is absorbing water but not forming solution. Hydrolysis, you are using water to break bond. So the answer to this question is what? Efflorescence. Is it not simple? If you've not subscribed, click on the subscribe button now. Let's move on to the next question. Hello my friends, let's look at question 3. In a chemical reaction, the change in concentration of a reactant with time is dash. Change in concentration of a reactant with time is dash. Don't cram. This one is a bonus question. Now look at this. Let's say we have candle. You've seen candle before, right? In real life, you've seen it, I think. You've seen it. Yes, this is candle. Now you agree with me, if candle is our reactant, the reactant is the substance that is undergoing the reaction, and you are burning the candle, you agree with me that as time is going on, the length of the candle will be reducing, right? While the wax will be forming. So the more the candle is reducing, the more the wax is forming. So you agree with me that the reactant in this case here is the candle, while the product form is the wax. Now, if you look at this, the rate of this reaction, how fast the reaction is processing, can be seen as, the rate of the reaction can be seen as the rate at which the candle is reducing, that is the rate at which the candle is reducing, or the rate at which the product is forming. So the rate change in concentration of the products of the reactants all over time, or you say the change in concentration of the products all over time. I'm putting minus here because you know the reactant is reducing, the length of the candle is reducing, so you put minus, then the product is summing, so no need putting minus. So the question now, it said in a chemical reaction, the change in concentration of a reactant with time is, so the change in concentration of reactants with time is dash. All right, now if you look at this, A says entropy of reaction. Entropy means the level of disorderliness, the level of randomness, the level of gara-gara, so to say, in a system. That's the entropy. Now enthalpy is the heat content of a system. The heat content is enthalpy, while the rate of reaction is the change in concentration of reactants with time, just like I've explained. Why order of reaction it is not. All right, so the answer to this question is what? The rate of reaction. So anytime you hear rate of reaction, just know that it is the rate at which the concentration is actually the change in concentration of the reactants with time. So if you want to look at the rate of the reaction of this candle, you're just looking at the rate at which the concentration, the length of the candle is changing with time. All right, that is rate of reaction. So this is the answer to this question. Let's proceed to the next question. If you've not subscribed at this point, please click on the subscribe button. I post videos like this that will help you throughout, so that you don't miss out. Click on the subscribe button and click on the bell notification. Let's move on to the next question. Question 4. The nitrogen obtained from air has a density higher than one from nitrogen containing compounds because the one from air is contaminated with dash, and options were given. Now it has been noticed that if you take nitrogen from the air and measure the mass, it is denser. The density is higher than nitrogen in nitrogen containing compounds. Why? Now one thing you should notice is that there are rare gases in the atmosphere. Rare gases are also called noble gases, and they cannot react. Take for example neon. The atomic number of neon is 10, and if you want to draw the shell configuration, this first shell is always having 2 electrons. So once you put 2, you move on to the next one. 3, 4, 5, 6. This one is always having 10 electrons. 10. Now if you look at this, 1, 2, 3, sorry, this second one is always having 8 electrons. 8 maximum. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've completed the 10. Now you see that the octet configuration has been achieved because all atoms will strive to get either the duplex or octet configuration. That is, would strive to complete 8 here. But neon is already complete, so there is no need to look for an electron. But if you have something like say fluorine, what is the atomic number of fluorine? You used to use it has little brain but cannot offer full. You see now, so it's 9. The atomic number of fluorine is 9. So if you want to draw the shell configuration, 1, 2. Remember, this one is always have maximum 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've completed the 9. If you see now, how many do we have in the outermost shell? 1, 2, 3, 4, 5, 6, 7, right? 7. But it's supposed to be 8. So fluorine now, we now want to get more electrons. Fluorine will look for where to get 1 electron from, because it will be easier for fluorine to give out, to receive 1 instead of giving out 7. So fluorine will now look for 1 electron to fit into this place. So we'll now write it as fluorine negative, because fluorine has accepted 1. So if we say fluorine is electronegative, so it can react. If you fluorine, in fact, fluorine will not exist as fluorine in nature, because once it's exposed, it will look for a way to attract 1. If you have something like sodium, the atomic number of sodium is 11. Now, if you draw the configuration, we're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is already 8. We cannot put again. We continue with another 1. So if you check now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, but this thing is supposed to have 8 in the outermost shell, octet configuration. Will it be easy for sodium to give out this 1 and have peace of mind, or to receive more 7 to beg 17? Which one will be easier? So it's very easy for sodium to give out this 1 than to be moving around begging 7, abi? So giving, is it good or bad? It's good. So sodium will now give out this 1, and it will now become sodium positive. So we say it is electropositive. This one is electronegative. So you see, sodium will always react. Fluorine will always react. But something like neon that is balanced, we said it's a noble gas, it's a real gas, it's stable, will not react. So they are just like that in the environment, but they are not reacting. Neon, argon, they are not reacting. They are just like that in the atmosphere. So if you notice, nitrogen that you take from the air, we have noble gases, we have rare gases. They are not reacting with them, but they will just be there, increasing the density of nitrogen. So back to the question, the nitrogen obtained from air has a density higher than 1 from nitrogen containing compounds, because the one from air is contaminated with what? Not water vapor, not oxygen, not carbon dioxide, but rare gases is the answer. Do you understand? Let's move on to question 5. Alright, question 5. The radioactive radiation used in studying arrangement of particles in giant organic molecules is dash. And options were given: gamma rays, alpha rays, X-rays, beta rays. Now, the answer to this question is simply X-ray. Now, if you have a crystal like this, a crystalline substance, X-ray is passed through it, and the X-ray will interact with the electrons found on this, the electrons found on this, and the X-rays will be diffracted, and it will form a specific pattern on a receiver here. So this is how it works. X-ray will hit the crystal, interact with the different arrangement of electrons, and the diffraction will form a pattern that gives the three-dimensional structure of that giant molecule. The process is called X-ray crystallography. X-ray crystallography. Besides, graphy means description. So crystallography, description of crystal using X-ray. Alright, so the answer to that question is X-ray. That's the answer to that question. Let's move on to the next question. Hello, my friends. We are making progress. Are we not? We are making progress. You see all these questions, though. You see all these questions, and good thing, I'm using the questions to be explaining. So if you see it in different formats, you can also answer them. All right, let's move on. Question 6. The process of converting starch to ethanol is dash. If you are converting starch to ethanol, what is the name of that process? Is it cracking? Is it distillation? Is it fermentation? Is it oxidation? So this question here, if you have starch and you're converting it to ethanol, please, another question can say sugar to alcohol. Anytime you are converting sugar to alcohol, usually yeast is assisting that process. Yeast is the microorganism assisting that process. The answer to this question is fermentation. So fermentation is actually the conversion of sugar or starch to alcohol. Ethanol is one form of alcohol. Do you get that? So fermentation is the answer to that question. Now cracking is just you are breaking long chain hydrocarbons to shorter chain. That's cracking. Long chain hydrocarbons, you break them to short chain. That's cracking. You know, distillation is the method of separation. And we've talked about fermentation. Oxidation, addition of oxygen, removal of hydrogen. All right, so fermentation is the answer to this question. Let's move on to question number 7. All right, so question 7, the basicity of this is ethanoic acid, is dash. What is the basicity? First of all, don't just guess. Last or you close the eye and just no. This is a bonus question. First of all, understand what is basicity. Basicity is the number of ionizable hydrogen in an acid. The number of ionizable hydrogen in an acid. It's not the total number of hydrogen, because some persons make that mistake. They'll just count the total number of hydrogen, 3 plus 1, 4. 4 they take. No, that's wrong. The number of ionizable hydrogen, what does that mean? If you have this, and this thing ionizes, you see that you have something like this. It is only this hydrogen here that will go out. It is only one hydrogen that can be given off. Though it has 4 hydrogen, it is only one that can be given off. So since it has just one ionizable hydrogen, we said the basicity is what? Is 1. If you have another thing like, say, HCl, what is the basicity of HCl? If you ionize HCl, it's still is one hydrogen that is given off. So the basicity is still what? It's still 1. If you have something like H2SO4, if you ionize H2SO4, that's sulfuric acid, you have two of this hydrogen can actually be given off. So the basicity of sulfuric acid is 2. So take note, basicity is actually the number of ionizable hydrogen found in a compound. Now, what is the basicity of this one? What is the basicity of this one? If you look at this, though it has 3, 4, 5, 6, 7, 8 hydrogen, but it's only this one that can be given off. So it is actually 1. Now, what is the cheat of knowing this? Anytime you have an acid like this, an organic acid like this, CH3, CH2, like that, any one, and it ends with COOH, it is only this H that is connected to COO that can be given off. So anytime you have an acid having this COOH functional group, just know that the basicity is what? Is 1, because it's only this hydrogen that can be given off. All right, so basically 1 is the answer to this question. Let's move on to question 8. If you've not subscribed, please click on the subscribe button. You're learning for free, and you see all these things in your exam. So click on the subscribe button, and as you click on the subscribe button, a bell will appear. Click on that bell notification so that once I post another lesson, YouTube will just send you notification. I'll go and learn Excellent Simplified. I've posted a new video, so you go and learn and you succeed in your exams. Let's move on to the next question. All right, question 8. A hydrocarbon has an empirical formula CH and a vapor density of 39. Determine its molecular formula, and options were given. Now, note that empirical formula is the simplest formula. Is the simplest formula of that compound, and they were given the empirical formula CH, and we're asked to find the molecular formula. One thing you should note is the molecular formula. I'm using F for formula, is just equal to the empirical formula. Let me use EF for empirical formula. Empirical formula times N. So molecular formula is just empirical formula times N. We look at what N represents. Now, we're given that question. In that question, we're given vapor density as 39. Now, one thing you should note is that relative molecular mass of a compound is equal to 2 times the vapor density. Is 2 times the vapor density. So now the relative molecular mass of this organic compound will be equal to 2 times the vapor density was given as 39. So this will be 2 times 39 will give us what? 78, right? So that's the relative molecular mass of this compound. Now, we've gotten 78 as our relative molecular mass. Now, we want to find our N. So how do you get N? Now, you have to note that what we have to do here is we already have CH, and this was our empirical formula, equal to 78. This is the simplest way to go about it. So CH into N equal to 78. So you are relating this now. You know, this thing now represents the molecular formula. So the molecular formula multiply this is equal to this. This is the relative molecular mass. Now, C, what's the atomic number? What's the atomic mass of C? Carbon. Carbon is 12, right? Is a non-fat. Carbon is 12 plus hydrogen is what? Hydrogen is 1. Then N is outside, equal to what? 78. Now 12 plus 1 is what? 13 times N. That 13N equal to 78. So to find N now, N is equal to 78 over 13, which is what? 78 divided by 13 is what? Is 6. Now we've gotten N. So now, for us to get our molecular formula, just N is now 6, right? So you just use 6 to open this bracket. So we had CH as our empirical formula, and to get your molecular formula, you just multiply by N. Now we've gotten our N as 6. So we'll be using 6 to multiply this. So this will be CH and 6 outside the bracket. So if 6 is entering the bracket, we'll be having C6H6, which is option D. So basically, if you have something like this, all you have to do, in this case, you are given vapor density. In some questions, they give you the relative molecular mass directly. But if it's vapor density you are given, to convert vapor density to relative molecular mass, you multiply by 2. If the question gave you relative molecular mass directly, you use it directly. So just put the empirical formula times N equal to the relative molecular mass. Then you find N. C is 12. Hydrogen is 1. You find N. After you found N, you use N to open the bracket, and you get the answer to that question. All right. Question number 9. Hope you are learning something. Be writing all these things down. Let's move on to the next. All right, here we have question 9, and it's actually a bonus question. Some persons used to run for me, but it's actually a bonus question. I will be giving you the trick, the cheats to answer this question. We're given this equation, zinc plus copper sulfates, to give zinc sulfates plus copper. In the reaction above, the oxidation number of the reducing agent changes from dash to dash. Now, all you have to do in this question is to identify, here they're asking the reducing agent. From after I explain this thing, you will know whether they say reducing agent or oxidizing agents, you know it. So pay great attention here. All you have to do in this question is identify the reducing agent and the oxidizing agent. Before I tell you that, anytime you hear oxidation, just take note of LEO. LEO. Loss of electron is oxidation. So in oxidation, electron is removed, and also oxygen is added. Also, hydrogen is removed. Anytime you hear oxidation, oxidation is electron is lost. Oxygen is added. Oxygen is added. So oxidation is actually gain of oxygen and loss of hydrogen. If you hear reduction, please check the spelling, spell it well. In reduction, is actually gain of electron. So electron is gain, hydrogen is gain, and oxygen is lost. So reduction, removal of oxygen, addition of hydrogen. Oxidation, addition of oxygen, removal of hydrogen. Good. Now, an oxidizing agent. An oxidizing agent is any agent, any substance that is causing oxidation reaction. An oxidizing agent is any agent that is causing the addition of oxygen. Right? And now an oxidizing agent, take note that an oxidizing agent is always reduced at the end of the reaction, on the product side of the reaction. While a reducing agent is always oxidized on the product side of the reaction. Are we speaking grammar? Let's go into practical. Let me show you what that means. From this question here, so let me use this question to explain what I mean by that. Zinc plus this equation. First of all, let's identify the oxidation reaction first and the reduction reaction. Now, anytime you want to do that, just pick one species, one thing on the left hand side, the reactant side, and pick that same thing on the right hand side. Then you study what is happening to them. On this side, let's take zinc and see where zinc is on this side. See where zinc is here. See where zinc is here. Zinc here, is there oxygen with zinc here? No, there is no oxygen with zinc here. Is there oxygen with this zinc here? Yes, there is oxygen with zinc here. Is it not? Here there is no oxygen here. Is there any O here? No. Here is there oxygen? Yes. So now the oxidation reaction here is from zinc to what? Zinc sulfate. Because remember we say oxidation is what? Addition of oxygen. So here there was no oxygen, but oxygen is added here. Now look at this one, copper sulfate. Is there oxygen with copper here? Yes, there's oxygen. Is there oxygen here? No, there's no oxygen. So you agree with me that removal of oxygen is what? Reduction. So the reduction of equation is copper sulfate to give what? Copper. Lazy. Now we are asked to identify before we calculate the oxidation number, it said calculate the oxidation number of the reducing agent. So what is the reducing agent here? What's the reducing agent? What's the reducing agent? If you check this oxidation is, and reduction is this to this. So what is the reducing agent? Which agent is causing reduction here? Which agent is causing reduction here? And remember, I told you the easiest way to know it is a reducing agent is always oxidized on the opposite side of the reaction. So zinc, is it oxidized here? Yes, zinc is oxidized here. So this is the reducing agent. This one, is it oxidized here? No, this one is reduced here. Reduced meaning oxygen is removed. So since this one is reduced here, this one is the oxidizing agent, because oxidizing agent is always reduced. Reducing agent is always oxidized. So the reducing agent here is zinc. The reducing agent is zinc. So we are going to look at the oxidation number of zinc here and the oxidation number of zinc here. Then we tell them our answer and we go our way. So now, if you look at this, since zinc is the reducing agent here, the oxidation state of every element on its own is 0. So if you just write zinc like that, the zinc is not attached to any other thing, it's 0. If you write copper on its own, 0. Sodium on its own, 0. The oxidation state of any element on its own is 0. So since it's not attached to anything here, zinc, the oxidation state is 0. So 0 to, now check here. We want to check the oxidation number of zinc here in zinc sulfate. All you have to do, we don't know that of zinc, is zinc we are looking for. Zinc, so we'll make it X plus. Now sulfur here, what is the oxidation? All right, now we've written X is for zinc because that's what we're looking for. Now sulfur, please take note, among all the compounds, sulfur is somehow. The oxidation number of sulfur changes depending on the compound it found itself. If it is in hydrogen sulfide, the oxidation number is -2. How did they get that? Sulfur is, the atomic number of sulfur is what? 16. So you use a shell configuration 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it can receive 2 instead of giving out 6. So receiving 2 is -2. So this one is used when sulfur is present in hydrogen sulfide. So if the compound is hydrogen sulfide, you use -2. But if it is sulfur dioxide, the oxidation state of sulfur in sulfur dioxide is +4. So anytime you see SO2, use +4. But if it is in tetraoxide, sulfur will prefer to give out this 6 instead of receiving 2. So if it giving is positive, so if it's giving out 6, then we have +6. So in this compound here, since sulfur is in SO4, then the oxidation state will be +6. Then now oxygen, the oxidation number of oxygen here, you agree with me that oxygen is 8. The atomic number is 8. So 1, 2, 3, 4, 5, 6, 7, 8. We still have 2 more to complete the octet configuration. So -2. Oxygen can receive 2 more, right? But we have 4 of it here. We have 4 of oxygen here. So we'll be having plus this is minus 2 for oxygen times this 4. Now equal to the charge, the net charge on this compound. You equate it here. So since there is no charge here, we say it's equal to 0. If there was a charge, let's say minus 2 here, you would have equated it to minus 2. But since there is no charge, we say it's 0. So here we'll be having x plus 6 plus minus 2 times 4 is what? Minus what? Minus 8, right? Equal to 0. So x will be 6 minus 8 is what? Minus 2 equal to 0. So x, if I collect like terms, x is crossing over. So plus 2. So you see that the oxidation number of the reducing agent is moving from 0 to what? To plus 2. 0 to plus 2. So the answer to this question is B. So this is it. Please take your time on this. On your own, find the reducing agent and the change in oxidation number of the reducing agent. So do that on your own. Let's move on to the last question in this series. All right, last question in this series. H2O plus C to give H2 plus CO. The oxidizing agent in the reaction above is dash. Now, in the last question, I explained how to find oxidizing agent and reducing agent. So use that idea and let me know the answer to this question. So solve this question and drop the answer in the comment section. Drop the answer of this question in the comment section. If you learned something, please click on the subscribe button and subscribe. Some persons requested that I make a video on dimension analysis in physics. Go and check. I'm dropping the video right away. I'm dropping the video of dimension analysis in physics right away because the question, JAMB questions are concentrated there. So go to my channel now and check. Watch that after this video now. All right. So if you're not subscribed, subscribe. Drop the answer in the comment section. I'm waiting for you. I want to see you succeed. See you next time. Have a nice day. My name is Excellence Simplified.